Hello grade 10 students, welcome to another virtual class. I am Miss Madhu Vadke. We have started with chapter 9, Some Applications of Trigonometry, in which we are learning how to find the heights and distances using trigonometric ratios. So far we have solved some simple word problems based on this concept. In today's video lesson we will understand the meaning of angle of elevation and angle of depression and apply it in solving some complex questions of heights and distances. To understand angle of elevation, let's consider this building which is standing on the ground vertically. So the angle between the ground and the building is 90 degrees. Let's consider a person who is standing over here. Let's say this person is looking at the top of the building. Then we can draw a line that joins the eye of this person to the top of the building. Let's mark this line as AC. This line is called as line of sight. We can draw another line from the eye of the observer which is horizontal and parallel to the ground. We will mark this line as AB. So this angle that is made between the line of sight and the horizontal level of the eye is called as angle of elevation. So notice that the angle of elevation is always formed when we raise our head to look at an object. So the line of sight is formed above the horizontal level of the eye. So angle CAB is angle of elevation in this figure. If we join C and B, we get a right angled triangle. So if we know the angle of elevation and any one side is given, then we can use trigonometric ratios to find unknown sides. Consider this figure in which we have a building standing vertically on the ground. Let's say there is a person standing here at the top of the building and looking at this car which is on the ground. We can draw a line from the eye of the observer to the object that he is looking. So in this case, this line AB is the line of sight. And notice that I have shown the arrow downwards from the observer to the car. Let's mark the horizontal level of the eye, which is going to be parallel to the ground. So this angle that the line of sight now makes with the horizontal level of the eye is called as angle of depression. So angle BAC is angle of depression. So remember that angle of depression is made when a person is looking below the horizontal level of the eye. That is, we lower our head in order to see that point. So notice that again we have a right angled triangle. We can mark this point where the foot of the building meets the ground as D. So triangle ABD is a right angled triangle. And we can use this triangle to write down trigonometric ratios which can be used for finding the unknown lengths of the triangle. A very interesting surveying instrument called as theodolite is based on principles of trigonometry. Using two large theodolites, the highest mountain in the world was discovered. From a distance of over 160 kilometers, the peak of the mountain was observed from 6 different angles or from 6 different stations. We know this peak today as Mount Everest, after Sir George Everest, who had commissioned and first used giant theodolites. These theodolites are in use today also. It is used for measuring angles with a rotating telescope. Today, the technology has advanced and we have digital theodolites. With this knowledge of angle of elevation and angle of depression, let's solve some questions of exercise 9.1. In previous video class, we have solved 4 simple questions in which we did not have to use the knowledge of angle of depression and angle of elevation. Henceforth, all the questions that we solve in this exercise are based on this concept. Starting with question number 4. The angle of elevation of the top of a tower from a point on the ground. As I had mentioned in the previous class, for every question in this chapter, we have to represent the situation given in it using a figure. So let's represent the first part of the question in the form of a figure. Since the tower stands vertically on the horizontal ground, the angle between them is 90 degrees. The angle of elevation of the top of a tower from a point on the ground. So let's say this is the point on the ground from where we are looking at the top of the tower. This means to look upward, we raise our head. So this is line of sight, and this is the horizontal level of the eye. So the angle made between the line of sight and the horizontal level, when the line of sight is above the horizontal level, is called as angle of elevation. And the angle of elevation is given as 30 degrees. Let's read the question again. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. So this point is 30 meters away from the foot of the tower. This is the foot of the tower. Let's mark this triangle as ABC, which is right angled at B. We have to find in the question the height of the tower, that is BC. We will proceed in the same manner like we did earlier. We will write down a ratio between unknown side and known side. So the unknown side is opposite to the given angle and the known side is adjacent to the angle of elevation. This means that we have to write down the trigonometric ratio tan 30 because that will be opposite upon adjacent. So tan 30 degrees is equal to BC upon AB. This is in triangle ABC. Now we can substitute all the values that we know. Tan 30 degrees will be 1 upon root 3. BC we have to find out and AB is 30. Cross multiplying, BC is equal to 30 divided by root 3. Now we have to rationalize this. So we multiply root 3 with numerator and denominator. This gives us 30 root 3 divided by 3, which is 10 root 3 meters. So the height of tower is 10 root 3 meters. Now this is a question where we had only one triangle. However, as we proceed in the chapter, the questions will become a little more complex in the exercise and will involve two triangles. Question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. Let's represent this much information in the form of a figure. So let's say this is the ground. We will represent a tall building using a straight vertical line perpendicular to the ground. Let's consider this boy who is 1.5 meter tall. This boy is standing at some distance from a 30 meter tall building. So the height of this building is given as 30 meters. Let's read the next part of the question. The angle of elevation from his eyes to the top of the building. So this boy is looking at the top of the building. Let's join these 2 points using a line. The angle of elevation from his eyes to the top of the building increases from 30 to 60 degrees as he walks towards the building. So right now the angle of elevation is 30 degrees. The angle of elevation is angle made by the line of sight with the horizontal. So let's draw the horizontal level of the eye. So AC is the line of sight and AB is the horizontal level of the eye. So angle ACB will be 30 degrees. Now as this boy walks towards the building, the angle of elevation changes to 60 degree. So let's say after walking a certain distance, this boy is standing over here. So the distance that he has walked is this. We will mark these points as D, E, F. So this boy has covered a distance of DE towards the building. Now when he looks at the top of the building, then his line of sight makes an angle of 60 degree with the horizontal. We have to find the distance he walked towards the building. That is, we have to find distance DE. So let's write down what is given. We are given the length of AD, which is 1.5, which is the height of the boy. Then we are given the height of the building, which is CF, which is 30 meters. Since the boy and the building are standing vertically on the ground, they make 90 degrees with the ground. So if we draw a line AD and GE, then AD, GE and BF are going to be parallel because these are lines that are perpendicular to the same line, that is DF. So the length of BF will also be 1.5 meters. This implies that CB will be CF minus BF, which is 30 minus 1.5, that is 28.5 meters. Notice from the figure that AD is parallel to GE and AG is also parallel to DE. This means that ADEG is a rectangle. This implies that DE will be same as AG, and the same explanation can be given for rectangle GEFB. GB will be same as EF. So I'm going to redraw this figure with only the upper part of this figure. That means I will minus the height of the boy from this figure. I have redrawn the figure minus the height of the boy, but I have incorporated this difference in the height of the building. Now what do we have to find out? The distance that the boy moves from the previous position to the new position. That means we have to find AG. Observe in the figure that we have two right triangles, triangle CGB and the other triangle is CAB. Remember, triangle ACG is not a right angled triangle. we have to pick only those two triangles which are right angled. So using these two triangles, we are going to find out AG. First, we will find out GB using triangle CGB. Then we will find out AB using triangle ABC, and then we will subtract AB and GB to get AG. So let's start with triangle GCB. We can form a ratio of CB and GB, where CB is opposite to 60 degrees and GB is adjacent to 60 degrees. So opposite upon adjacent is tan 60. So we are writing ratio tan 60 equal to CB upon GB. Tan 60 is root 3, CB is 28.5 and GB is what we have to find out. So on cross multiplying and rearranging the terms, we get GB as 28.5 divided by root 3. Let's rationalize this. By multiplying root 3 to the numerator and denominator, we get 28.5 divided by 3 into root 3, which is 9.5 root 3 meters. Let's take the other right triangle, triangle ACB. To understand, we can separate this triangle. So in the second triangle ACB, BC is the opposite side to 30 degrees and AB is the adjacent side. So again we can form a ratio which is opposite upon adjacent, and that is tan 30 degrees. So tan 30 degrees is equal to BC upon AB. Substitute value of tan 30, that is 1 upon root 3, BC as 28.5 in this expression and cross multiply. So we get AB equal to 28.5 root 3 meters. Now in order to find AG, we will subtract GB from AB. So AG is equal to AB minus GB, and we have found AB as 28.5 root 3 and GB as 9.5 root 3. So when we subtract these two, we get 19 root 3 as the distance moved by the boy towards the building. With this, we come to the end of this video lesson. Your assignment for today are these two questions, which are based on the concept of angle of elevation. See you in the next class. Until then, goodbye.